Okay, to start this video out, I just want to do a quick review on inverses. So note that f of x to the negative first power is the sign for an inverse. So when you're solving inverses, you do 3 steps. The first step is to switch the x and y value. Then in your second step, you solve for y in terms of your x value. And finally, you're going to rename your y as f of x to the negative first power. And I'll be demonstrating this in an example. So in our first example here, the very first step we need to do is we're going to be rewriting f of x as y, just to make it a little bit easier on us later on. Then in our second step, we're going to be switching our x and y values, so our new equation is going to be x equals negative 2y plus 4. And then we're just going to solve for our new y value here. And that gives you your answer of y equals negative 1/2 x minus 2. And then just for housekeeping, in our we have to do our last step, which is going to be changing y to f of x to the negative first power, like so. Okay, so here we are. Here's the logs, the things that a lot of people have a lot of problems with. Logs are the inverse of an exponential function, so it's like a way of taking the exponent and bringing it down to the other equation, and you could use this a lot for solving equations with a variable in an exponent. This is your standard log equation, y equals log of a of x, and a is a positive, real, non-imaginary number other than 1. Mostly in math, we look at 2 types of logs. Your common logs, which usually have the a being a 10, so log base 10 of x. The other one we use is natural log, and you'll see this sometimes. This one would be like ln of x, which is basically log to the base e of x. And don't get too scared by the e. You can't really solve for this without a calculator. All e is it's a way of expressing things over a manner of time. So it's like continuous rather than incremental. So as I said earlier, a log is the inverse of an exponential function. So I just wanted to show you this on a graph. And I can do this little thing here to prove, although it doesn't work too terribly well. Oops, sorry. You can kind of see that these functions go in opposite directions of each other. And what that means is that they are reflected over the x equals y axis, which, as you could assume, is just like whenever x and y are the same. So this would be like making ordered pairs of like 1, 1, 2, 2, or 3, 3. So to prove this, I'm just going to do a quick example here. When a function and its inverse are composed in any order, they will equal the same value. So just for the sake of this, I'm going to say that we're going to have x equaling 2. So we just have to fill in for that in our first section right here. So let's just fill that in. This is a 10 log. So we're just going to do 10 log of 2. The log and the 10 cancel out, bringing the 2 down into the equation. So your answer is 2. So we're going to do that again in this equation here. The a is still 10, so log of 10, and in this case x is 2, so 10 to the second power. And because this is log base to the 10, you cancel those out, bringing the 2 down once more, and your answer is 2. We both have x equals 2, so they are inverses. So that's the end of this video. Join us as we talk about logs and their properties in the next.